Good morning. Welcome to Sai Krishna classes. Today we will see the most important topic that is Tableau. Introduction to Tableau. Let us start with the first concepts. So what is Tableau? We have to answer two important questions. First one, what is data visualization? And second, why is data visualization important? First, we will see what is data visualization. Data visualization is the process of describing information through visual rendering. That means here, whatever the data that we collect, the data should be described in the form of visual rendering. So here you can see, here in the left hand side we have the data, a lot of data, enormous data that has been represented in the form of visual rendering. That it may be in the form of histograms, it may be in the form of bar graphs, plots, etc. Geographical representation, dots. Here we can see that is data visualization. So why is data visualization important? Technological advances have made data visualization more prevalent and powerful than ever before. This is the main reason why this data visualization has become important. Nowadays, you can see the technology is advancing day by day, and due to this advancements in the technologies, we are going to have more prevalent and powerful. This data visualization has become more prevalent and powerful than before. And mainly data visualization used for business purpose. What is Tableau? Tableau is groundbreaking data visualization software created by Tableau software. Tableau connects easily to nearly any data source. Tableau allows for instantaneous insight by transforming data into interactive visualizations called dashboards. So here we can see how this Tableau is helpful in the data visualization. So Tableau features. Let us see what are the important features of Tableau. The first one is speed to market. Second one, Tableau is easy to use. Third one, Tableau does big data. And fourth one, Tableau does any kind of data. And stunning and interactive plots can be achieved by Tableau. Tableau is an industry leader. Connecting to data. Let us connect Tableau to the data. So, connecting to data, especially we can connect to first one Excel, database and cloud. Adding another data source. A workbook can have multiple data sources. We can connect to a locally saved extract or to a data source which is published to Tableau online or Tableau server. Live versus extract. Data preparation with text and Excel files. So first we will see what is data interpreter. With no columns names and a lot of nulls, data interpreter strips out them and the columns are properly identified. Next, what is pivot? The pivot merges the information from the original columns and rows into two new columns. Metadata grid. It can have a useful view with a large number of files and when tables have been joined. Split. We can split the columns based on the shade delimiter of that hyphen. Custom split. We can choose our delimiter and use a hyphen. Using data interpreter. Here we can see the first one represents the connections. That means how the connections have been established from the Excel. We take the columns and add them. We use the dash sheets, we use the data interpreter. Here data interpreter might be able to clean your Excel workbook. So from this we go to the sheets, that is click on review the results. Here we are going to have the data interpreter. What is the clearing? An Excel file is generated with the interpreted null values. Here you can see, look the A's, the values that we are going to have to get with A values. For example, 3A, 45A, 85, 70A, 71, 72A, 73A, 74A, like that. So here we have generated at the end an Excel file with the interpreted null values. Saving and publishing data sources. Saving a data source makes it easily available in your copy of Tableau desktop. We need to save the data source as a .tds, or it can be published to Tableau online or Tableau server. This is not the data itself. A note on file types. Workbook .twb. Workbooks hold worksheets, dashboards and stories. Bookmark .tbm. Bookmarks contain a single sheet. Packaged workbook .twbx. Archive containing a workbook along with all data sources and files. Data extract .tde. Local copy of a subset or entire data source to share and improve the performance. Next, data source .tds. Shortcut to oftenly used data sources containing information and modifications. Packaged data source .tdsx. Archive containing a data source file along with any related files. Join types with union. Joining tables is a way of combining information from multiple tables based on a field of the share. Joins are always made on a specific field or fields. Here we can see joining of the tables. On the left hand side there are two tables. Here we are joining them. That means we are combining the information from multiple tables based on a field that they commonly share. Joins are always made on a specific field or fields. Union follows the behavior union all, even if there are duplicate values for some rows. Union appends new rows and new columns if the shred field doesn't match across the union data sources. Cross database join. Here, for example, we have taken two attributes, sales and products. Data from different sources can be joined. Here, that is nothing but cross database joins. Here we make use of the integrated data sources for this purpose. What is data blending? Data blending is a way to combine data from multiple data sources into a single view. Blend relationship and how to blend. For example, you can see the data that is arranged here. So blue, what does this blue represent? The primary data source. If you take some orange, it is secondary data source. So for our analysis, we are identifying them with different colors. Links, orange. Here we can see use the common field for linking. Gray, don't use the common field for linking. Here we can see the data analytics. Here we have a coffee chain with the blue color. What does it represent? Blue color, primary data source. Here office city, that is represented in orange. That means it is a secondary data source. So here what are the dimensions that are available? Area code, date, product, product line, product type, region, state, territory state, type, measure names. Okay. Here again, if you see in this, dimensions that are available are city, client ID, client name, goods category, goods name, goods subcategory, order ID. Again here we can see the region, row ID and state. What are the common field that are available? We should check. For example, region is the common field we can use for linking. So visual analytics, let us give some meaning to the data. What is visual analytics? Visual analytics is a field in information visualization that focuses on analytical reasoning facilitated and supported by interactive visual interfaces. A picture is worth 1,000 words. We all know the famous proverb that a picture is worth 1,000 words. That means whatever you are going to represent or whatever you want to express, if you express it in the form of a picture, it is closely stored in the mind rather than writing in the form of a words length text. Okay, so always representing in picture is worthwhile. So here humans are very good in solving complex problems. Visual representations enhances, that means improves the human cognitive process. Here cognitive process is the ability to think. So what Tableau has to offer? PT1. Powerful ways to select and aggregate the data to consider. Hierarchies, groups, sets and filters. What Tableau has to offer? Make use of the visual analytics power easily and effectively. Reference lines and trend lines to visually evaluate the plots. We have forecasting to make predictions with a confidence level, statistical tools like average lines, median and box plots, k-means bundled clustering. How does it look like? Let us see how a data visualization, how it is going to look like. Here we can see different pages, columns, rows, and the representation of this in the form of a order. How it is represented in the form in a visual type. See here how the data has been segregated, how the data has been analyzed, visualized in the x-axis, y-axis, taking all the columns into consideration. We are representing them. This data visualization is a beautiful tool. This Tableau, if you can see, nowadays the data visualization has become so much popular that everyone is moving towards it. Dashboard and stories. Let's make it more visual. What is a dashboard? Powerful tool for mixing multiple views in a unique one. It allows us to create interactive and common filters for all the sheets grouped. Excellent tool for generic views. Dashboards example, here we can see the dashboards, how they are represented. For example, they have taken the shipping date, shopping cart. For example, we have Amazon, Flipkart, okay, etc. So these online sites, they will be helpful for shipping the goods or shipping the products. Okay, with this kind of data visualization, it will be very helpful. The average shipping cost, you can see here what is the priority cost, how it is represented with the different beautiful colors. What is a story in Tableau? Sheet that contains a sequence of worksheets or dashboards that work together to convey information is called a story. All methods that are able for data sheets and dashboards apply to stories. Powerful navigation tool for presentations. Here you can see the example for stories. Why have driving fatalities decreased in the United States? So driving fatality is a very important topic in the United States. Why? Because there have been so many fatalities previously. That means so many people were used to die. So they have taken the steps to reduce these fatalities, and they have adopted some technologies, some techniques, so wherein which they are going to give good results. So that have been represented in the form of a story, you can see here. Calculations. That means, or we can say, how to manipulate the data set. Types of calculations. Calculations are manipulate the data set over which Tableau is running. The operations are performed by the underlying database. Table calculations manipulate the current view. Operations are performed on the view by Tableau without passing through the underlying database. Calculations on what? That means on what we are going to perform the calculations. you will perform the calculations on string, logic, date, type, etc. Calculation syntax. How do you perform the syntax for calculation? What is the syntax? Here you can see example calculation. If text general code equal to example, then do something. Else if text general code, here you can see example 2, then do nothing. Else do something else. And here we are making use of if then. If else if. Okay, so here we are taking the dimensions and we are taking the measures in one attribute, and here we are performing the calculation field, create calculation field. By this calculations we are performing. Next, level of detail expressions. Level of detail expressions introduce the capability to specify the exact level of aggregation within a calculation itself. So my dear friends, you can see here when you calculate the level of detail, we are performing the aggregation. That means we are adding, we are taking the average, we can say. The data, for example, there are sales in the month of January. Again in the month of February, March. We take the quarterly, aggregate them as quarterly. Or if you require it, take it as half yearly. Or if you want to, you will aggregate it as yearly. This totally aggregated data will be represented, will be finally taken into this particular granularity level. Okay, that is called level of detail. It expressions, level of detail expressions introduce the capability to specify the exact level of aggregation within a calculation itself. For example, in the supermarket data sales analysis, it will be helpful. Mapping similar tools and Tableau online. Let's give some meaning to that data. What are the possibilities? Nowadays we can see the possibilities are infinite. Online maps, we have WMS and Mapbox. They let you create your own custom background map or connect to one. Automatically recognize and display geographic data and associated metrics at different geographic granularities. Tableau's competitors are SAP, Pentaho, Splunk, Looker, QlikView, Power BI, and Insights Squared. Tableau desktop versus the rest. Now let us compare our Tableau with the rest of these competitors. First, download and installation. Power BI, okay. Pentaho, okay. Qlik, we can download. Next, data connection. Power BI, we can do it. Pentaho, Qlik. Data manipulation, it is not available in Pentaho and Qlik. Graphic ability is available, and cost, Power BI is not. Better to choose Pentaho, it is questionable, it is doubt. And next, Qlik, it's not possible. Here Pentaho asks for a specific price depending on the desired solution. We suppose that in the average is more expensive than Tableau. What has to offer Tableau online? Skip hardware cost and setup time, connection with other users, support live data connections, and secure. Thanks for watching.